Grade 12 Physics, Special Relativity, Note 5. Energy mass equivalence. So Einstein showed that energy and mass are basically the same thing. And we've seen his equation before. It's one of the most famous equations in physics. We can see that E equals mc squared. So what this means is that energy is equal to mass times the speed of light squared. It means that energy and mass are exactly the same thing. They just exist in different forms. And we can convert energy into mass, and we can convert mass into energy. E is in joules, m is in kilograms, and c is the speed of light. If we check the units, joules and kilogram meter squared per second squared. If we remember the kinetic energy equation, a joule is a kilogram meter squared per second squared. So that left side equals right side. Let's use it in an example. Let's say there's a nuclear explosion where we had 54.7 kilograms of reactants and 54.5 kilogram of product. So we lost 0.2 of a kilogram in the explosion. That 0.2 was converted directly to energy. So how much energy would that be? E equals mc squared. So we find the difference of the mass, times it by c squared. It corresponds to 1.8 times 10 to the 16 joules. That's a heck of a lot of energy. Next, if coal contains 3.2 times 10 to the 7 joules per kilogram, if burned in a coal-fired plant, so every kilogram is going to produce 3.2 times 10 to the 7 joules, how much mass would be needed to get the same amount of energy if we were to use it in an E equals mc squared explosion? So if we require 3.2 times 10 to the 7 joules, let's figure out how much mass that is. So we're going to use the equation, put the amount of energy we need in, divided by c squared. It corresponds to 3.6 times 10 to the negative 10 kilograms. So in a nuclear power plant, that's how much mass would be needed to make the same amount of energy.